this video, we're going to be looking at recursive equations for arithmetic and geometric sequences. So for an arithmetic sequence, the recursive equation is an is equal to an minus 1 plus d, where d is the common ratio. And remember also with these recursive equations, we also have to state what our first term is. So I would have a1 equals some number. Geometric sequence, that's going to be an is equal to r times an minus 1, where r is the common ratio. And again, you would also put your first term there. So for these examples, we're going to write a recursive rule for the sequence. So this first one, I have 3, 13, 23, 33, 43, and so on. So to write the recursive rule, I first have to determine whether this is an arithmetic sequence or a geometric sequence. So in other words, to get to my next term, am I adding or subtracting, or am I multiplying or dividing? Here I see the pattern is that I'm adding 10 each time. So since I'm adding 10 each time, this clues me in that this is an arithmetic sequence. And so I know I'm going to be using this first formula right here, that an is equal to an minus 1 plus d, and what a1 is. So to write that, that means I need to know what my a1 is, so I need what my first term is, and I need to know what my common difference is. Well, here my common difference I see is 10. So I have an is equal to an minus 1 plus d, which is an minus 1 plus 10. My a1 is just my first term, and I can see from my sequence that that is 3. So when I go ahead and write my rule out, I say that a1 equals 3 and an is equal to an minus 1 plus 10. Okay, let's look at this next one. So here I have 16, 40, 100, 250, and so on. So to get to 16 and to 40, I add 24. To get from 40 to 100, I add 60. So that's not the same, so I know it's not arithmetic. So that clues me in that this is actually going to be geometric. And so to determine what r is, I'm going to take that second term and divide it by the first term. And when I do that, I see that I get 5 halves. And if I were to do that with every term, I'd see I'd also get 5 halves. So 100 divided by 40 is equal to 5 halves. 250 divided by 100 is equal to 5 halves, and so on. And so that tells me that this is geometric. I am multiplying by the same thing each time. So I have my r is equal to 5 halves. I need to figure out what my first term is. And looking at my sequence, I see that that is 16. And so I need to replace r with 5 halves. So a1 is equal to 16. And an is equal to r, which is 5 halves, times an minus 1. Okay, let's look at 2 more. This next one, I have 2, 14, 98, 686, and so on. Since I'm getting to bigger numbers so quickly, this clues me in that this is again going to be geometric. And I see to get from 2 to 7, I just need to multiply by 7. Multiply by 7, multiply by 7, and multiply by 7. So this is geometric. And that means that my r is equal to 7. So I have an is equal to r times an minus 1. So I have 7 an minus 1. And so now I can go ahead and write my rule. So I need my first term, and I see that that is 2. And so I can write a1 is equal to 2. An is equal to 7 times an minus 1. Okay, let's look at one more. This next one, I have 19, 13, 7, 1, negative 5. Here I see the numbers are semi-close to each other. So that kind of clues me in this is going to be arithmetic. And I see to get from 19 to 13, I subtract 6. 13 to 7, I subtract 6, and subtract 6. So that means this one is arithmetic. And so that means that an is going to equal to an minus 1 plus d. Here my d is -6. That's what I'm subtracting each time. So I have an minus 1 minus 6. So write my rule. I first write my first term, which, look at my sequence, I see is 19. And then I write my recursive rule, which is an is equal to an minus 1 minus 6.